Okay, we're in for review. And I've written down several problems. These problems came from a worksheet that I've handed out. It's posted at the assignments page. And it's a PDF. It says something about, well, let's see what it says. Make sure I read the correct title to you. All I've got to do is find it. Well, it'll be identified as a review document. So I'm gonna, right here while everybody's watching me, I'm gonna label it review document, and then a big long URL. And you should be able to download that. If you have trouble downloading it, email me and I can reply with a copy. Okay? I can attach it. So anyhow, these are typical problems that you might see, and using these to kind of refresh your memory. And we want to work these problems and then check our solutions. Okay, that's the key thing you need in preparing for the exam. You need to know how to check your solutions to see if they're right. And we've talked a lot about that. But okay, the first problem, we want the line through two given points. Okay, so let's number these. I'll call this number 1, number 2, 3, 4, 5, 6, 7, 8, and 9. And we're going to go through these fairly quickly. We've got about 30 minutes left. But it's got to be good and condensed. And this should not only refresh your memory, but give you an idea of how to work these problems and check yourself. Okay, so we got the point 2, -3. Now I would usually draw a line for x equals 2 and a line for y equals -3. So the point 2, -3 is right here. So let's label that 2, -3. Now I recommend you do all of this. Okay, then we have x equals 5. Well, if that's 2, then 5's out here a little more than twice as far from the y-axis. There's x equals 5 and y equals 2. And here's the point 5, 2. And here's the line through those 2 points. Now, first thing we want to do with the line is we want to figure the slope. There's a formula for slope, but I think it's important to understand geometrically. So what I've said, and if you want to use the formula, go ahead, look it up. Just don't forget it, because if you use the formula wrong, it's not going to be worth much on the exam. So we get this fundamental triangle, which I'm going to sketch a little bigger so I can label it. Okay, so this arrow, now these arrows go from the left point to the right point. You don't want this arrow pointing to the left and this one pointing up. They have to give you a path from one point to the next. And I say, just make the convention, you go from left to right. You could go from right to left. Your arrows would be down and to the left, but that is probably confusing. So we label the run equals 5 - 3 equals 2. And people are doing that. You know, I've seen some good work on the fundamental triangles here. And then the rise is 2 minus -3, which is 2 plus 3 or 5. So the slope equals rise over run equals 5 over 2, and I put a box around that. This is how I want to see these labeled. Now, this is for your sake. If you get the slope right, I'm going to accept it. But if you write out everything that I'm writing out, and there's evidence, I see people, doing a pretty good job of writing things out, but you want to be very specific, write everything out, do several problems of each type, write out all the details, and they will stick with you much better. I just saw an article by some psychology journal that says, writing reconfigures your brain in a different way than typing, in a different way than just sitting back and watching. Writing is a thing that helps you get everything into your brain, okay? So write it out, draw the pictures, do what you have to do. Okay, so we have the slope here. Okay, so we know we have to find the slope. Now, the form is y equals mx plus b. M equals 5/2, so y is 5/2 x plus b. Now, just pick one of the points. Let's say we pick the point 5,2. And I'll pick the 0.52 just because both of the coordinates are positive and we don't have to get confused with a negative sign. If we can help it, we try to avoid that. But of course, if we do have negative signs, we treat them carefully. Okay, so 5,2 means x equals 5, y equals 2. So we get the 0.2 equals 5/2 times 5 plus b. And we solve for b. Okay. Well, we have a denominator, 2. We're going to multiply the whole equation by 2. And I'll write it out like this. A parenthesis around the whole side and then multiply it by 2. Now we'll just go up here because I don't have room. Okay, and we get 4 equals 2 times 5/2 times 5 plus 2 times b. Distributing the 2 through both sides. We get 4, then equals, okay, 2 times 5/2. How do we do that? Well, I'm going to write the 2 as 2 over 1 so that we can see that the denominator is going to be 1 times 2 and the numerator is going to be 2 times 5. We have a 2 in the denominator. We have a factor 2 in the numerator. So the 2's divide out. We don't need that 1. And we get 5 times 5 plus 2b. Of course, 5 times 5 is 25 plus 2b. And then we subtract 25 from both sides. And we get negative 21 equals 2b. So b equals negative 21 over 2, which is like negative 10.5. Now, somehow that doesn't seem quite right, but looking at my scale seems right, but it looks like, b is going to be your y-intercept. Okay, negative 21 over 2 would be like negative 10. This is negative 3. It doesn't look like that's negative 10 there. This is y equals negative 3. That's more like negative 5. So right away, I'm a little concerned about my solution here. We do have the point 5,2. So we put in 5 for x, and this is what we get. Put in 2 for y, we get this. I don't like this solution. I don't see what's wrong with it, but work it out and see if you can fix it. We conclude that y equals mx plus b is then going to be y equals 5 half x minus 21 halves. Now, if I plug x equals 2 in here, I don't get y equals -3. So I've obviously done something wrong in this solution. But the slope is 5/2. I honestly don't see what step is wrong, but I'm not going to dwell on it. Obviously, I've done something wrong, so go ahead and work it out yourself and check, because here I'm checking. What I do is I substitute the coordinates of the point that I didn't use. We substitute 2, -3, meaning x is 2 and y is -3. And okay, so we're going to say that -3 should equal 5 halves of 2 minus 21 halves. So -3 should equal 10/2 minus 21/2. Of course, 10/2 minus 21/2 is -11/2. No, doesn't work. We got to find our error. I'm going to leave it at that because I honestly can't see I did some bonehead thing there and can't identify it. All right. Now, in all the earlier confusion, failed to clean enough boards to do this stuff. So I've got to take a minute and take care of that. Okay, now, second problem. Is this, and we want to simplify it. And I think everybody identified that the x plus 6 is a factor in your denominator. It's also a factor in your numerator. You don't like to say cancel, people cancel wrong. It divides out. But if you verify that something is a factor of both numerator and denominator, if it's something that's multiplied by everything else in the denominator and it's multiplied by the rest of the numerator, then you can use that C word. You can cancel it, okay? But you can't like cancel the 6 with the 6 and leave the x's, okay? Because the 6 isn't a factor of the numerator. The whole x plus 6 is multiplied by the numerator. The 6 is not multiplied by the whole numerator. in a way that'll give you the same numerator. A little confusing. You just learn to identify factors. Okay. So x plus 6 times x plus 5 over x plus, it's not x plus 5, it's x plus 2 here. X plus 2 times x plus 6 equals, now I like to write it out. You don't have to write out this stuff, but I think it's a good idea. X plus 5 over x plus 2 times x plus 6 over x plus 6. If I multiply the numerators, I still get the same numerator. If I multiply the denominators, I get the same denominator. So this equals x plus 5 over x plus 2. All right. Now, if you're going to cancel, be sure that you know the rules and write out how you're doing the rules so you don't do an incorrect cancellation on the exam, because it's automatic unless there's a whole lot else involved in the thing. You automatically lose a whole lot of credit. Okay. Okay. Now 4 over x plus x over 6 equals what? Well, over here we'll write what we're doing. Common denominator 6x. So this equals 4 over x. To make the denominator 6x, we have to multiply the denominator by 6. What are we going to multiply the numerator by? Because we're going to have to multiply by some fraction for the 6 to be in the denominator and multiply that x. Well, the only thing we can multiply by that doesn't give us a different value for 4 over x is 6 over 6. I mean, it's got to be 1. We got to multiply by 1. Otherwise, we change the value of 4 over x. We multiply by 6 over 6. And over here, we've got to multiply by x over x. Whatever we multiply by, the numerator has to be the same as the denominator. And it's always safe to do that. It's not always going to lead you to the right solution if you do it wrong. But as long as you correctly multiply by something over itself and do the multiplication correctly, you're going to get something that's equivalent to your original equation. And even if you somehow mess it up, it could be recovered. Now, that's 24 over 6x plus x squared over 6x. I'm just going to say multiply each term as needed. I don't want to write out a whole paragraph about being careful that your numerator is the same as the denominator, okay? And then we add the numerators to get 24 plus x squared over 6x. Now, what do you do with that? Well, the problem was to add those things, okay? That's it. That's the pattern you use. Go back to what we did originally in adding fractions with numbers. Make sure you're doing the same operations. A lot of times it's easier with symbols. The numbers can get pretty big, get pretty complicated. The symbols are just what the symbols are. Okay. Now solve this equation for r. And everybody did quite well with this one. I was pleased. Okay, so this number 4, we have 2r plus 6W equals 5R. Okay, what people essentially did was they added a negative 5R or a negative 2R. I guess it was a negative 2R. Now I like to write the next step out without confusing, because this negative 2R is under the 6W. That indicates that somehow we maybe do 6 minus 2. It doesn't matter how you have it aligned if you write it out correctly. Well, 5R, yeah, 5R minus 2R. And now we see that, well, we can't subtract a 2R from the 6W. We don't know what R is and we don't know what W is. They're unlike terms. So we do the 2R minus 2R, that gives us 0, and we get 6W equals 3R. And 6W over 3 equals 3R over 3. If we divide 3R by 3, we get R. If we do the same thing to the other side, we divide the 6W by 3. And we get 2W equals R. And usually we like to have the thing we're solving for on the left. R equals 2W. If you get this, it's right. If you get this, it's a little more grammatical. Okay? And number 5, simplify. You got x to the negative 5, y to the third. People are a little sketchy with this. Two to the negative 1 to the fourth is two to the negative 1 times 4, because a to the b raised to the c is a to the bc. Now you want to go back and be sure you understand these rules for exponents. Like what we really said was a squared to the third power would be an a squared times an a squared times an a squared, which would be a times a multiplied by a times a multiplied by a times a. Count them, there are 6 of them. 6 a's multiplied together gives you a to the 6th. Okay, always check out these rules and make sure that that you have them right, using like 2 and 3 for a and b. Okay, anyhow, then we have y to the 5th here. And this is z. So negative 1 times 4 is negative 4. So all we've done so far is just taking care of that z to the negative 1 to the 4th. Okay. Well, this equals x to the negative 5th over z to the negative 4th y squared. Is y cubed over y to the 5th. 3 of these y's divide 3 of these y's and go away, and you end up with a y squared. Now there are different ways this can be written. So we got we could write it with no denominators. X to the negative 5th. The reciprocal of z to the negative 4th is z to the 4th. The reciprocal of y squared is y to the negative 2. We don't have time to go into complete explanation of that, but we demonstrated that pretty completely back 6 weeks ago, whenever we did this. So you want to review that in Open Math or in the posted videos for this class. So that's one form. This is with no denominators. So sometimes you're asked to do this with no denominators. Or in this form, where we have no negative exponents. So an x to the negative fifth in the numerator becomes an x to the fifth in the denominator. And a z to the negative fourth in the denominator becomes a z to the fourth in the numerator. So there we have the form with no negative exponents. Okay. Now I'm going to go ahead and try to get at least one more done here in 2 minutes or so that we have. Okay, so this is number 6. Notice that there's a negative in front of this 4x. Okay. Your y-intercepts are at 0, 2, and 0, 1 because the y-intercept occurs when x equals 0. All right, x equals 0 in parentheses there. Okay. Then the x-intercepts occur when y equals 0. And that's a little bit tough to do because you're going to get like x equals 1/2 and x equals negative, x equals 1/4. X would be negative 1/2 or x would be 1/4. Okay. So that would, like, for the first one, give you a point over here, and then you'd be going up. For the second one, give you a point here, you'd be going down. Best way to graph these is to use the slope. The slope is 4. So we go over 1 and up 4. And we get a point here. Okay. And the slope here is negative 4. So we go over 1 and down 4. Given if y equals negative 2, and the line here is x equals 1. Then we connect these 2 points. Sorry. This point is on the second graph. We connect this point with this point. And we get a point here, which we can estimate the coordinates of. Okay. We can also do it algebraically. Now, we're out of time. Probably have to go. So I will redo this graph and continue this in a separate video that I'll post a little bit later. And then we'll look at the last few problems. And I do apologize. Between Adobe and printer and everything, we wasted a fair amount of time today. But Should have worked right the first try. Okay, well, that's it. So I've enjoyed the course. I'm not sure where everybody was today, but of course, last day before finals. Um, you know, feel free to stop by. Email me if you have a question, you can't find me. And good luck on the final.